Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com webinar, brought to you by Techstrong and Fairwinds. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we've got an exciting panel for you today. First, I have just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session. If you have any questions, we want you to go ahead and send those in to us using the Q&A tab, which can be found on the right side of your screen. That's also where you're going to find the chat tab, and that's where we want you to get to know your fellow audience members. Let us know your thoughts throughout today's webinar, or maybe just let us know from where you're tuning in. And finally, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around for the entirety of today's program. So our topic, or should I say question today, is how much does Kubernetes cost? And I'm joined by Bill Lettingham, CEO of Fairwinds, Robert Brennan, Vice President of Product Development at Fairwinds, and Kendall Miller, Technology Evangelist at Fairwinds. So Kendall, Robert, Bill, thank you all so much for being here. I'm going to let you go ahead and take it from here.
Thanks, Cody. We'll go ahead and dive in. Hello, folks. Welcome. This is How Much Does Kubernetes Cost? We're going to be digging into Kubernetes, the cost of Kubernetes, why it's difficult to measure, why it matters, what to do about that. So let's go ahead and get started. And Bill, you want to start? Introduce yourself.
Sure. Thanks, Kendall. Hi, everyone. I'm Bill Lettingham. I'm CEO of Fairwinds, and looking forward to the discussion today. Really diving into some of the challenges of understanding cost within Kubernetes, given that Kubernetes is somewhat of a black box from a cost perspective. So, looking forward to the discussion today.
Thanks. And Robert, you want to introduce yourself?
Yeah, I'm Robert Brennan, VP of Product Development here at Fairwinds. I lead up our development efforts on our commercial product, Fairwinds Insights, as well as maintain some open source like Polaris and Goldilocks.
All right, and hi folks, I'm Kendall. I'm a technology evangelist here at Fairwinds, been here for a very long time, and excited to dive into this topic with you today. We are going to be having much more a discussion. It's not going to be slide heavy. We're going to be talking through some of Bill's background as head of engineering at other organizations and some of the problems he's run into in terms of cost, what's different about Kubernetes, et cetera, and it's going to be much more discussion-y. So please do feel free to make use of that Q&A tab as we go, because if you have questions that are relevant, we're happy to answer them at the time. Otherwise, we'll have some time for Q&A at the end. We're also going to be talking a little bit about what Fairwinds does and where that fits. But before we do that, we have a poll for you. Where are you in your Kubernetes journey? And Cody will bring this up. Are you just learning about containers in Kubernetes? Are you planning to use it in 6 to 12 months? Using it only in testing or development environments? Or are you all the way up to using it in production? And I will say the vast majority of times that we do this, the results lean heavily in terms of, at the very beginning of that, just learning about containers in Kubernetes or using it in production. So I'm curious to see today if, well, maybe me saying that taints the results. I'm no statistician, but let's see. Those are the two biggest buckets that we have right now. I'm using it in production, or I'm learning about containers in Kubernetes. So feel free to keep answering that for a little bit. We'll leave that up for just a second more, and then the poll actually stays open in the background. So if you don't get to it right now, you can go respond to that later. But yep, seeing that normal distribution, just a little percentage of y'all in the in between. So sounds like people go from. My conclusion from this is that people go from learning about containers in Kubernetes straight to using it in production. Nobody ever spends 6 to 12 months or uses it in testing or development first. And we'll wrap that up in 5 seconds. And all good. Thank you. Okay, so I'll tell you a little bit about Fairwinds and why we're here talking to you about this today. So Fairwinds has been in business for, about 7.5 years now. And we've been a Kubernetes company exclusively for the vast majority of that time. It is our goal as a company to help other companies with security, policy, and governance so you can ship cloud native applications faster, unifying dev, sec, and ops. So Kubernetes is still a new paradigm for the vast majority of organizations. We build software, open source, and SaaS that helps companies address the complexity of this, because Kubernetes is complicated. Part of the reason it's so flexible is that it's complicated. And almost everybody who's using it is afraid they're using it wrong. We have a long background helping companies run Kubernetes, and as a result, we've built a bunch of open source software that helps address some of the macro level problems that we've seen people struggle with. Everything from cost management, which we're talking about today, to security, efficiency, reliability, all the different bits. And then we've married a bunch of that together into a SaaS platform where we can really help companies have confidence in using Kubernetes, confidence in service ownership within Kubernetes. So at the end of this, we are going to show a brief demo of that software, so stick around. We'll dive into that. But for now, let's get to the topic at hand, which is the cost of Kubernetes. And I'm going to stop sharing my screen. With Google Hangouts, every time I stop sharing my screen, I actually close the browser. I like hang up every single time, so I'm terrified of doing that in the middle of the webinar, but success. Okay, well, let's dive in. So why is cost harder in Kubernetes? And Robert, do you want to start there?
Yeah, so back in the old days where you would run, each application on its own virtual machine in the cloud or its own machine in your data center, it was really easy to associate a single item on your bill with a single application, right? You would have, one line item per instance on your AWS bill, say, and each of those instances could be attributed to a single application. You just total them up, and that's how much that application cost. With Kubernetes, you're really slicing and dicing those VMs and bin packing a bunch of different workloads onto each VM, and a single workload could be spread out across multiple VMs. So you really have to look inside the cluster to understand exactly how much of each VM to allocate to each application. And some of those VMs might also be unallocated. There might be some idle space inside each VM. And so the question of okay, where do I put that idle capacity? Who gets billed for that? Are all kind of interesting open questions when you move towards a container-based environment like Kubernetes.
Yeah. And I want to then, so it's complicated in Kubernetes, but let's back up even a second further. And Bill, you have a long background as an engineering leader in this space. Why does it even matter? Why do we need to care about costs other than the obvious? We don't want to spend all of the VC money on one. Cryptocurrency mining, or help us understand why that even matters.
Certainly not these days on cryptocurrency, but I think that the challenge is partly due to the success of cloud native and to the success of Kubernetes as an architecture for hosting applications. So as more and more companies into containers running on top of Kubernetes, the cloud spend associated with that environment is starting to rise at a pretty fast rate. And as a result, a lot of the engineering organizations are getting pressed by finance to better kind of justify and show an understanding of why those costs within the cloud are growing, and how do you attribute some of those costs to specific applications that are running in that cloud native environment. So the success of Kubernetes is really driving an increased focus and a better understanding on the cost side as to where are these costs coming from. And as Robert said, there are challenges with Kubernetes as a technology, really drilling in there, understanding how to attribute those costs. And then I think more importantly also, just the nature of how applications have been re-architected to run in cloud native environments. The fact that you have a number of microservices, shared services, in addition to the workloads running in containers, that also presents additional challenges as to how do you kind of attribute some of this shared service to that application. Where do you really need to drill in as you see kind of service costs increase in one particular area? Where is that really coming from an application perspective? And it's certainly, a challenge that I had at my last company. I was CTO and head of engineering of Black Duck, and we had rolled out a SaaS application running in Kubernetes. And as we brought more and more customers onto that platform, we saw our costs really start to increase. And as a result, we were getting pressure from finance to, better justify, where that cloud spend was coming from, and also, be able to better forecast, what that cloud spend was going to look like going forward as we added more customers to the platform.
Yeah, the blessing and the curse of the cloud is you no longer have to buy your own hardware and host all your own things on that hardware. But that's the blessing. The curse is that it's really hard to know exactly what that cost is. When you own all your hardware, you know exactly what it costs you to buy that hardware. You scale exactly as big as you have hardware to scale, and you pay your internet bill, and that's about it, right? But in the cloud, click button, scale up to infinity, and that's amazing, especially because I can start a small startup in my basement and never need to own the hardware that it runs on and grow it to millions of users. Well, in theory, I can. If I could, I would be doing that.
And as you said, Kendall, in the past, it was, very easy to associate costs. You had to actually go out and buy a server to run your application, your workload, your test environment, etc. These days, it's very easy for a developer to, spin up a new container running in a pre-production environment, and lo and behold, they forget to turn off that container, and all of a sudden you're seeing your costs spike up, and you don't know where is that coming from. And so, this ability to kind of drill in, get a better understanding of, where these workloads are running, why they're running, should they be running, how much, they're costing, becomes more and more important.
Yeah, as a developer, I think it's really easy to just, mess around, change a few lines of YAML, and suddenly, your bill's up by 50%. So I think you should be careful these days. You have to make sure you have eyes on everything you're spending and where that spend is going.
Well, and I think without good tooling that's monitoring it regularly, it's not uncommon for organizations to have no idea until they get the AWS bill. And I have a friend who was the head of a large cloud infrastructure team, and a service that was costing $1,000 a month for months and months and months. 1 month cost $60,000, and they had no idea until the bill came. And sitting down and looking at that and go, wait, what? Where did that come from and why? And it takes a while to drill down into so-and-so set this one thing wrong. And it is, like I said, both the blessing and the curse. But yeah, because those costs can run away, finance wants to know, because it's not a controllable cost. So finance wants to make sure you're controlling it, or at least have eyes on it, or have some kind of control in place, especially in a more mature environment or a more mature organization where you've enabled service ownership. Where I've said, Robert, I need you to go build a thing, and I need you to own it all the way through to production, and don't screw it up, or it's going to cost us an arm and a leg. And Robert might have no idea how to make that actually work without good tooling to look inside. So we talked about why it matters that we know what's there, because finance cares, because you don't want to put your business out of business. Let's talk a little bit about Kubernetes and how it's sort of auto-scaling things. And Robert, you talked a little bit about the old world. Let's talk about the new world. I hand a workload to Kubernetes. What happens? And it just kind of takes it and runs with it? Is it going to just scale forever? What are the limits that I can put on Kubernetes to keep it from... Can I tell Kubernetes never spend more than $100,000? Is that a setting I can put in my email?
Yeah, it's a great question. So Kubernetes typically deals not so much in terms of dollars, but in terms of CPUs and gigabytes of memory, and in terms of replicas, right? So it's super important to take advantage of those levers that Kubernetes does give you. In particular, setting up your workload to use a specific amount of CPU and a specific amount of memory. You can reserve a set of, you want to use one CPU per instance, or 5 gigabytes of memory per instance of your application that's running. And you can also set a limit. So you could say, I want to reserve 1 CPU, but have a limit of a maximum of 2 CPUs for this workload to run. And that's super important because it gives Kubernetes a sense for, how much resources your application needs to run, what a normal range of resources is. So if, say, you have a memory leak and you've said, okay, I need a limit of 1 gigabyte per memory per instance of this application, and suddenly it starts trying to use 2, 3, 4 gigabytes, Kubernetes knows, okay, this application is misbehaving. I'm going to kill this instance of it, start a brand new instance of it that doesn't have the memory leak, at least for a little while, hopefully, and you can kind of control your costs that way. And the other setting that you should be thinking about is auto scaling, which is basically a sense for how many replicas of the application should be running at one time. So there's a concept called the horizontal pod autoscaler, which will determine how many replicas are potentially available and when to go up and down within that range. So you might say, I want a minimum of 2 replicas and a maximum of 10 replicas, and I'm going to scale based on maybe the depth of a queue or the amount of CPU being used, things like that.
And so then, given there's all those things that need to be set and that Kubernetes needs to tweak and run with, on the one hand, it's amazing. You just tell Kubernetes, these are the limits in my request, and it does all the rest for you, right? But Bill, when you're the head of an engineering organization, and in theory, all your people have to do is, make sure they include a line with settings. If you just go tell them, hey, everybody set resource requests and limits, A, is that going to work? B, do they know what to set them to? How do you control this?
Well, yeah, on the positive side, it's great to be able to kind of set how much, CPU and memory your workload needs to run both reliably and, with good performance. You want to be able to have that fine-grained control to ensure, quality of service of the application or workload. The challenge is, what I found quite often is developers will arbitrarily set those requests and limits fairly high. They just want to get their application running. They don't, frankly, really care about how much cloud resource they're using under the covers. And so as a result, with everybody kind of doing that same type of behavior, that's where you can find a lot of times workloads are, truly over provisioned for what they actually need in terms of resources within the Kubernetes environment. So quite often we're finding, workloads are over provisioned, 25, 30% more than what they actually need. And so being able to kind of drill in there, understand how much is that workload actually using, how much does it really need, and to kind of tune some of these parameters so that you are optimizing your use of this underlying infrastructure. Yeah, even though Kubernetes will auto scale, it will auto scale kind of according to what the workload is asking for. And so you do have to be a little bit more careful around that in particular.
Yeah, that's great. And so let's pause. There's a question that came through, and I want to encourage others to ask questions. So I'm going to go ahead and we're going to answer this right now. This person says, I'm trying to understand the hidden costs with GKE, if there's anything that doesn't show as a part of Google Cloud's pricing calculator. So I'm going to take an initial stab at that, and then Robert, correct me if I'm missing anything or getting this wrong. But I think that when you're looking at the Google Cloud pricing calculator, Google's asking you a lot of things about your workload, how it's going to scale, how much, what kind of resources it takes today versus tomorrow. And particularly when you're looking at GKE, Kubernetes itself costs very little to run. It's just a very simple control plane, and then everything else is all the workloads. It doesn't take a lot to run Kubernetes. What the complicated part is getting all of the, what we've touched on here already, getting all of the workloads to be correctly configured so that they're going to scale up or scale down the appropriate way. And I think it's really easy with the Google pricing calculator. It's the same thing as what we're talking about here. You have to set resource requests and limits. You can set those wrong. And when you sit down and fiddle with the Google Cloud pricing calculator, even all of your assumptions that are going into that, it's not necessarily hidden costs. It's that you might not actually have a realistic idea of what things cost you to run. And Robert, first of all, correct me if I'm wrong about any of that.
So I'm not personally familiar with the Google Cloud Pricing Calculator. We're an AWS shop, but if it's analogous to AWS's billing calculators, there's no hidden costs in terms of like the calculator is going to generally match your bill at the end of the month. What's hidden though is kind of the internals of what's contributing to that cost. So at least with AWS, we have no ability to kind of introspect inside of Kubernetes and understand. We've got 17 applications running inside of our Kubernetes cluster, and here's the breakdown between those applications about which each one cost within the cluster. It's just the cluster as a whole cost us this much money, and that's what shows up in the calculator. That's what shows up in the bill. So if we want to look inside and say, okay, inside this cluster, which teams are spending which amount of money, which applications are costing us the most money here, then we really need some extra tooling on top of that, cloud provider calculator to look into the cluster and kind of split up those costs.
So pause for a second and let's make a plug for, we have an open source project that helps you get these resource requests and limits just right so that your cost will match your actual spend. Robert, talk a little bit about Goldilocks. Why do we call it that? How does it work? How long does it take to get useful information? Where's it getting that information from?
Yeah, so Bill touched on this earlier, but one thing we see very often is that development teams will just set their CPU and memory settings to something, arbitrary and fairly high because they just want to get their application running. That's kind of, the mandate they've been given by the business is, get the application running, keep it up and stable. But they never kind of go back and make sure that those memory and CPU settings are, actually sane, actually, somewhat close to what the application is really using. So Goldilocks actually monitors an application in production and says, okay, this is the amount of CPU and memory I'm seeing used over time. Here's what you should be setting your requests and limits to based on what we've seen in production. And so you can actually use Goldilocks. It'll give you a dashboard. You can look workload by workload. Here's what they should be set to, and go back to your YAML settings and change those CPU and memory settings. It plugs into metric server on using VPA under the hood, the vertical pod autoscaler recommendation engine. So you can get recommendations pretty quickly, right after installing it. The longer you let metric server run, the longer it has been running inside your cluster, the better those recommendations are going to be.
Yeah. So rather than to be clear, there's several different ways to set resource requests and limits. One, pull numbers out of thin air. That's what most people do. And then they kind of run it and they're like, oh, it seems like it's underperforming. Maybe I should tweak, right? Two, use a tool like Goldilocks. It's open source. That means you can go click a button and install it on a cluster right now. And it's going to pull out data that's actually watching real world usage and therefore making suggestions that you can rely on. And then you can go back and tweak if things change over time, right? The other thing is at scale, it's really hard to do that. If you have more than one cluster, if you have a whole bunch of workloads or a whole bunch of clusters across different environments, running Goldilocks in a whole bunch of clusters and going back and checking that for each individual workload over and over and over again and changing your YAML files is kind of overwhelming, which is part of why we make a SaaS product that addresses this, and we'll show you that again in a little bit. At scale, operationalizing that gets a lot easier with a SaaS product. But the other thing is just the third option is just wildly under provision or wildly over provision everything and cross your fingers and assume it's going to be fine. That's kind of like pulling numbers out of thin air, but when you pull numbers out of thin air, you might revisit. And there's an awful lot of companies that never revisit. They just okay, well, it runs, so it must be fine. And meanwhile, they're spending. I mean, we have seen organizations in a proof of concept just testing our software save $250,000 by realizing they were wildly over provisioned. That's how much people mess this up because it's really easy to get it wrong. Okay, along those lines, Bill, why can't I just go pay for Cloud Health or one of these other, aren't there tons of cost tools out there that I can just install and find out what I'm doing?
Yeah, no, there are a number of cost tools, but the challenge is most of these tools have really been architected to the world that Robert was describing, where you can get a good understanding at a per VM level within the cloud. But it's hard, in the case of Kubernetes, to kind of drill into the cluster and get more specific numbers around what each workload, what each application is using within Kubernetes. And that's the challenge. And what I was referring to before is Kubernetes being a little bit of a black box in terms of how do you partition out the cloud spend around each of these resources and attribute them back to the application or workload that's actually using that resource. So think of it as a big bucket. You're spending $100 a day on this bucket, but you want to be able to say, okay, this application is costing $10. This is costing $2. This is costing $5. And right now, within Kubernetes, that can be difficult to do unless you set up your environment to take into account different, labeling, namespace information, et cetera, within Kubernetes, so that you can start to attribute costs to different workloads and applications. And I'm sure Robert can go into a little bit more detail on that, but at a high level, it's all about how do you split up, your cloud spend in Kubernetes and attribute it down to an application or workload level.
Yeah, no, I think you nailed it. I mean, Kubernetes, the beauty and difficulty of Kubernetes is that it goes into your cloud environment and it creates this big shared pool of resources that you can deploy any application into. So you've got this huge pool of CPU and memory that AWS or GCP just sees as one item on your AWS bill essentially. But that shared pool of resources can get divided up in all sorts of interesting ways. Any application can go into that pool and start using some of those resources. Some of the pool might be idle, and there's a question of where does that idle capacity get billed to? Which team does it get billed to? So it creates more efficiency because you now have kind of a liquid set of CPU and memory that can go to any application that needs it, and applications can scale up and down independent of one another. But at the same time, you create an extra layer of abstraction that you now need to be able to look into, and the cloud providers just aren't set up to be able to do that. And the big cloud cost platforms that grew up around the cloud providers that aren't Kubernetes specific platforms really don't have any visibility into what's going on in that shared pool.
Yeah. So I like to think that, I think of Kubernetes as kind of as big of a paradigm shift as the cloud was. In the same way that moving from servers to the cloud is just this wildly different paradigm shift. Instead of owning your own hardware, installing on physical machines, you're literally giving your workload to somebody else. You don't know if your workload's running on 3 physical hardware devices or a quarter of a physical hardware device, and you don't care. And it's kind of similar with Kubernetes. Now there's that much more abstraction, and everything is just fine, and Kubernetes handles a lot of the automation behind the scenes. You still have to define those things, but it is a new paradigm. It's complicated. That's why just about anything that's been around doing cloud monitoring, cloud cost monitoring is just very different because it was architected in a time when everything was different. This is a new paradigm. It's hard to see into what Kubernetes is doing. So I want to talk for just a second more, and then we'll dive into a demo and we'll talk about some specifics when we can see something within Insights. But before we do that, let's talk about like a concrete sort of, as concrete as we can be when we talk about a customer. So like PagerDuty is a customer, and they're a large SaaS platform. I don't know everything about how they use our software, and if I did, I wouldn't talk about it in this webinar, I guess. But in theory, let's say they have a pretty advanced service ownership style engineering environment. I don't know if they do. I'm just in theory, large SaaS application like PagerDuty. We've built Kubernetes. We've given people the ability to deploy applications into Kubernetes, own those applications or services all the way through to production. What does it actually look like? Just that workflow, Robert, for like, I had to come up with something, I had to see if it works, I have to guess what how much CPU it's going to need, I have to define those things, I have to deploy it, I have to test it, and then I have to push it to production. Just talk for a second through some of the specifics of the complexity there, especially from the perspective of an engineer who's not intimately familiar with Kubernetes because they don't want to be. They're a Go engineer or a Node engineer or whatever. What does that workflow look like, and how does cost affect that engineering?
It's a pretty in-depth process to go from like, a Go or a Node.js application that, runs fine on your local machine. It's all stored in a Git repo. What you have to do is first you have to Dockerize it. So you have to put it into a Docker container, which will then get shipped off to Kubernetes. You have to define how much CPU and memory you should give it. So your local machine probably has much more CPU and memory than you are necessarily going to want to give it in production. There's the added complication that you don't really know what your traffic is going to be like in production. So even if you get it working nicely in staging with a certain amount of memory and CPU, there's no guarantee that production is going to behave the same way. You might have different bursts of traffic, things like that in prod. So you kind of have to start with a little bit of over provisioning. It's typically the pattern we see. People will give it an excessive amount of CPU and an excessive amount of memory, and allow it to scale to a large number of replicas, just to start, just to make sure that when you do that first launch to production and you start getting real production traffic, you have more than enough room to grow. And then it's important to, once you've seen it in prod for maybe a week or two, you have a good sense for, what a weekday looks like versus a weekend, what nights look like versus days, things like that. You have a good sense for your baseline production traffic. Then you can start to tune that CPU and memory back down to a normal amount. You can tune down your auto scaling down to, what is a reasonable amount before you'd want to get an alert saying, hey, you're scaling up a lot more than usual. So that's typically the flow. You start with a very over-provisioned workload, watch it for a week or two, and then start to pare back those resources to make sure you're not way overspending.
Great. Okay, well, let's dive into a demo and actually show you Fairwinds Insights. So, actually, there's one more thing I want to pull up. So Fairwinds makes software that makes this easy for you. You can go out, as we've said, fiddle around in the dark and hope for the best, or you can leverage software that's going to make it easier. And let's just show you a couple different options for that. So the first I'm going to show you is, make sure I get the right window here. Is some of our open source. So Goldilocks we've mentioned, and it's hard to see the logo here in the dark. I have GitHub in dark mode, but Goldilocks, get your work resource requests just right. You can check out our GitHub. It's fairwindsops/Goldilocks. But this is what it'll give you is a dashboard like this that's going to show you, based on the quality of service that you want, and for a particular workload, this is what your current requests and limits are. This is what we think you should set it to for that quality of service. Very simple application. It leverages what's going on underneath the hood with the Kubernetes vertical pod autoscaler. We don't advise you to just turn on the vertical pod autoscaler and let it do its thing where it's constantly changing those resource requests based on what it's seeing, because that causes some messiness. We do advise that you leverage this, get the information out of the vertical pod autoscaler, and then set your own resource request and limits. So that's Goldilocks. Now, as I mentioned, at scale, that's a lot harder to operationalize. And so Fairwinds Insights is our SaaS platform that exists to help you have confidence that you're using Kubernetes right at scale across your entire organization. And when you have one Kubernetes cluster for everything, go find a couple of open source projects, install it on that, maintain those open source projects. That's no big deal. If you have more than a few clusters, more than one cluster, it starts to get really difficult to keep everything up to date and having a high level overview of everything that's going on. Also, if you want more fine-grained control over cost, Goldilocks is going to tell you what to set your resource requests and limits as, but Insights is actually going to tie that to a dollar amount for you so that you have insight on the workload level, et cetera. And I'm going to show you that here in a second. So when you log into Fairwinds Insights, you're going to get an overview of all of your clusters and health scores for them. So you can see, we've got US West staging and West prod, and we've got London prod and GovCloud staging and all these different clusters. And if I click into one of the production environments, it's going to load me up with a dashboard for just that cluster. And here we're showing action items. So Fairwinds Insights checks for a whole bunch of different things. I'm going to focus today on the cost bits, but people use this for security, for reliability, and other things as well. So we are checking across the entire cluster, all of the workloads that are running in it. Are they configured correctly? And these action items are when issues are introduced into the cluster. Anything above the bar is new action items being introduced to the cluster. Anything below the bar is when we have knocked off those action items. And so things should be improving over time. You can see, health score used to be 90. Today, we're all the way up to a 95. So that's changed over time. We give you that big high-level health score. There are 2,626 checks that are passing in this cluster, but we have 25 critical action items that need to be addressed. So we'll dig into what some of this is. Here's a high-level overview of the cost of the cluster over time. And let's dig into where this is all coming from. So where are we collecting all this from? We marry together a whole bunch of different open source projects and build some proprietary information on top of that. So Polaris is one of our open source tools that checks for common Kubernetes misconfigurations. We've been doing this a long time. We saw a lot of people do things like run a container as root or set an image pull policy to something other than always. And so, that's why Polaris exists. We also have Nova that checks for out-of-date Helm charts, Pluto checking for deprecated APIs, but we pull in third-party open source as well. Trivy checking containers for known vulnerabilities, KubeBench, KubeSec. We also have support for OPA, the Open Policy Agent. So you can write custom policy and enforce it within Fairwinds Insights. And that all rolls up into a big list of action items where you can sort by severity, you can sort by the cluster, etc. And you can click into any one of these action items. It's going to tell you what's wrong, and it's importantly going to tell you about how to go about fixing it. So you don't have to be a super senior Kubernetes engineer to take a look at what's going on here and go in and fix things over time. Now, if you're like me, and if I was a platform engineer running this at scale, what I don't want is to log in, see 5,000 things that need to be fixed, and it's all my job to fix, because that's very overwhelming. What I would rather do is put in place guardrails so that things improve over time, because people are no longer allowed to deploy things in an inappropriate manner, deploy broken things, insecure things, misconfigured things. And so we have shifted this left into the CI/CD pipeline. Here's an engineer interacting with GitHub the way that your engineers normally would. So the platform team or an SRE team or whatever you call them at your organization can set same defaults. And that is as simple in Fairwinds Insights as saying, hey, anything that's critical or above, we want to keep from being deployed into the cluster. And then Fairwinds Insights will sit in CI/CD or at the admission controller level, but also scans in runtime, but it will stop things from being deployed into the cluster when they're misconfigured. So here's an engineer pushing some code with some broken bits, and you can see Circle CI is passing it, Fairwinds Insights is failing it. And the engineer just clicks details, loads them into the GUI, and shows them what they need to fix for that deploy to go through. So this is a big deal for platform teams, so they don't have to keep being the help desk that everyone goes and just says, hey, something's wrong, can you fix it? Hey, something's wrong, can you fix it? We're actually enforcing this in a way and in a workflow that developers understand. Okay, all that said, today there's way more happening in Fairwinds Insights than I'm going to show you today. We've got policy, we've got some compliance bits, we have automation so you can kick out issues into Jira or Slack or wherever your workflows are. If you're all interested in this, reach out and we'll show you more in depth. But today I want to show you about the cost bits, because that's what we're here talking about. How much does Kubernetes cost? And so in our efficiency tab, we're going to give you an overview, and this is actually the cost of these clusters. And you can see most of these clusters cost about the same thing because it's a demo environment, but we graph that over time. US East staging is our most expensive cluster, and you can see where these things have changed over time, as well as track utilization. How much are we using? Are we over provisioned, under provisioned, etc. Big deal from here is like cluster overview, super helpful. Knowing, hey, Bob's running a cluster that's using 500 times more than anyone else in this organization. We should go ask Bob what he's doing and see if he'll share some of his crypto before we fire him, right? That's an extreme example, but you get the idea. It's also helpful to be able to dig into workload specific bits here. So here we have a breakdown by workload within a cluster. I'm in the Proxima prod cluster. We show you relative total cost, the relative daily cost of each individual workload. And then down here, you can see here's a workload that we've set a quality of service as guaranteed, and you can change this if you know that something doesn't need to be guaranteed. It can be limited or burstable, or it's critical, and we will tell you what the average total cost is today, and if you take our recommendations, what the costs will be. So here I've sorted by the workloads that we're going to see the biggest benefit from. This one's $8 a month. That's no big deal. We're only running 3.7 pods. But you can see how at scale or wildly over-provisioned things, you click a few buttons in Fairwinds Insights, and across all of your clusters or across an individual cluster, all of your workloads, you can see, hey, this is wildly over-provisioned or wildly under-provisioned. To be clear, Fairwinds Insights will tell you that too. Hey, you've set way too low resource requester limits. If I click into this workload, it's going to pull up a graph that shows me here's my limit way up here, here's my recommended requests and limits, because you can see that the workload never actually got above this. So there's no reason for my limit to be this high. I'm requesting a lot more than I need. So we're telling you this is what is currently set, and this is what our recommendation is. So on the memory side and on the CPU side as well. And this is how you get to this level of granularity. What are things costing me? Why are they costing me that? How do I fix it? Where can I save money and where can I not afford to? Because what you don't want to do is go in and start slashing costs and cause your website to go down or cause a bad experience for your customers, right? Fairwinds Insights really approaches the problem not from we're just going to save you tons of money, although that's often the outcome, but rather from the perspective of we want you to have things configured correctly so that your organization is using Kubernetes in the right way. The cost matches the spend. Your users are having a good experience. We're addressing all of those things in this. Okay, anything that I'm not sharing here before I move out of demo, Robert? Anything to add?
No, I think you covered everything.
Okay. So let's then, somebody's letting my dog into my office. So then let's talk just briefly, well, I'll stop screen sharing here again, about what kinds of places we're seeing organizations use this. I mean, we've got fintech organizations, we've got SaaS organizations, right? Anybody who's using Kubernetes runs into these problems. Am I wrong about that? I mean, maybe at some very small scale, you're just not worried about it because you know your bill's only $5 a month.
Yeah, I mean, if you're a brand new startup, it's probably not that big a deal. If you've got one team deploying in, you've got a single Kubernetes cluster or one app, you probably have a pretty good handle on, that app is taking up your entire Kubernetes bill. But the second you have multiple teams, multiple apps, all running inside the same Kubernetes environment, things get a lot more complicated. You need a lot more granularity in terms of your visibility into the bill. And that's where you really start to benefit from a platform like this, which can pull in all those costs from all those different environments, all those different teams, and help you slice and dice them in a way that makes sense for your business.
Great. Now let's pull up this last poll, and then while you're filling this out, if you have any questions, we've got some time for some Q&A here, and then we have a couple of resources we can share with you as well before we let you go. And I know Cody needs to come on and do a wrap up towards the end here, but tell us about the greatest opportunity to improve your Kubernetes environment. Are you struggling with just getting help with the basics? Do you want a general best practice assessment? Are you looking at improving the security posture of your clusters? Is it all about saving money? Maybe you're here today because it's all about saving money. Are you looking to improve the reliability of apps running in Kubernetes? So take a second and fill this out. And we'll pull that up here in a second once enough folks have responded. And okay, well, let me see if I can come in. Yeah, here we go. Okay. So it looks like most folks are in the getting help with the basics or saving money, with improving the reliability of apps running in Kubernetes coming in behind that, or a general best practices assessment in last place. So if you're interested in any of that, Fairwinds has resources for you. Check out our website. We've got white papers on basically every one of these topics. Fairwinds Insights will help you with all of this, whether you're moving to Kubernetes and you just want to avoid all the common pitfalls, or you have an extremely mature organization and you're trying to set defaults across your organization for policy enforcement in managing cost, Fairwinds Insights fits. If you're using Kubernetes, you're going to benefit from using this platform, and it's probably going to pay itself off quicker than you expect, unless you have very few workloads and very little spend and no problems, which doesn't usually describe most Kubernetes users. Okay, we can wrap up that poll, and here I've got a link to a couple white papers. One white paper, Kubernetes, the good, the bad, and the misconfigured, how to eliminate Kubernetes misconfigurations to reduce risk and improve reliability and cloud efficiency. So go check that out. We really do want to solve the entire problem for people from related to misconfiguration, from security to efficiency to reliability, and that's where Fairwinds sits. So any questions before we let you go? I'm not seeing anything come through Q&A. Now's your chance. Yeah, Dave's posting in the chat. We will send a link to this paper to everyone after this event. It'll also be recorded. Any final words, Robert, Bill, before we turn things over? Feel good?
No, thank you for joining. This has been
Yeah, thanks very much for your time today, everyone. Appreciate it.
Yeah, thanks so much. And Cody, we'll turn it back over to you to wrap things up.
Sure. We do quickly just have one question. So what is the best way to get started?
Oh, okay. Yeah. Well, I mean, if you want to get started with, say, Fairwinds Insights, I mean, depends on what you mean by where to get started. You can go check out a white paper like this. Go check out some of the resources on our website. If you want to take a look at Fairwinds Insights, a demo is free. We can go much more in depth. In the demo, we do a good job of digging into how are you using Kubernetes, what are your pain points, and our team will give you a very tailored, here's how we would actually help you. There is no cost to that demo, and there is no obligation to buy. So, feel free to reach out to any of us at Fairwinds if you're interested in that. Yeah, all yours, Cody.
Well, Kendall, Bill, Robert, thank you all so much for joining us and sharing your expertise. I'd like to quickly remind our audience that the session was recorded. You will receive an email shortly after we conclude with access to the recording on demand. You can also find the recording living on the Container Journal website. Just visit containerjournal.com/webinars and be sure to look in the on-demand section. So as always, we have 4 $25 Amazon gift cards to give away. Our first winner is Shivani B. Our second winner is Tim Y. Our third winner is Anthony R. And our fourth and final winner is Fausto D. So to the 4 of you, congratulations. Keep an eye on your inbox to claim your gift card, but if you don't happen to see that email, please check your spam folder. I would like to thank Fairwinds for sponsoring today's webinar. And to our audience, we really appreciate you spending time with us today. We ask for 1 extra moment of your time to fill out a brief post-webinar survey that'll pop up on your screen here in just a moment. But otherwise, we do hope to see you at an upcoming Techstrong learning program. Everyone, have a great rest of your day. And Robert, Bill, Kendall, thank you once again.